Hey guys, Shouvik and welcome back to our tech channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes, so today we have count equal and divisible pairs in an array. So what they have given to us? They have given a zero index integer array nums of length n and an integer k. Now we have to return number of pairs I and j, where I is smaller than the j. I and j are basically indexes, so they basically bound to lie on the index of 0 to n, and I is smaller than my index j, such that nums of I and nums of j both are same, and the index multiplication is divisible by k. I think it's very straightforward also, as per what they have written. So if you can go to the test cases also, like that is the nums is given to you and that is the k value is given. Now there are four pairs that meet all the requirements. If num0 and num6, 0, 1, 2, 3, 4, 5, 6. So here you can see both, like these 3 and 3 are equal, and 0 cross 6 is 0, which is divisible by 2, Agree, right? Now this way you can find other pairs also, and for this case you can, it's very obvious the answer is 0, because there is no elements which are repeating. There is no repeated element, so we don't have any pairs as such which is meet all the requirements. The requirements basically, the first requirements all together, like both are same. Yeah, so on that case we are returning 0. I think the question is very straightforward, and the brute is very typical. I'm not going to any one note explanations today for the brute, because brute is, I think, very straightforward. So brute, this code will work as a brute, so where you can start a loop from j to n minus 1, or anything I, you can start from 0 to n minus 1, and j from I plus 1 to n, anything's fine. And for every j you can start your I loop from j minus 1. That should be just before my j, I should be just before my j. And if this multiplication condition satisfied and both are equal, then you are increasing your count. And finally, when after this, so this for particular j, how many I we have it. So this is something like so you can write the forward loop also. I just write a backward loop, but there is no delta in time complexity as how you have just written the loops. So here the thing is, if so what I have written, let's suppose you have this array, so I am writing a j loop from here, and I am starting my I loop, and I am starting my I loop from this to this. I am starting my I loop from just a next of this to this, just a next of this to this, and I am checking for this j, how many I can put, considering this j as fixed, how many I can put, how many I can get. If I can get this, then I think our job is done. So yeah, that's exactly things I did. I am running a j loop from backwards, and I loop I am starting from just before my I, and I am doing the same things. Now that is the extreme brute, but there is a kind of optimizations, but the time complexity for this is like big of n square, and space complexity for this is also constant, not a big of 1, not also. So the space, we are not using any extra space, that is a constant of big of 1, that's for sure. Now what modifications we can do, like what we are doing, like let's rewrite a forward loops. So I think that is more intuitive also. Backward loops I just written if for like making a big of n kind of solution, but there is no possible big of n kind of possible. After data like heavy pen paperwork, I identified there is no big of n kind of solution exists for this problem. But please guys, if you are able to find any big of n kind of solution, please provide in the comment section. That would be helpful for all of us. Yeah, so now on the forward loops or a backward loop, anything's fine. Like if we write a forward loops, we will start from 0 to n minus 1, and our j loop is going to start from where? Is going to start from I plus 1 to n minus 1, or we can write it to n minus 2. The outer for loops not need to make it to extreme, right? Otherwise we have no options to select it. That's a slight optimization you can do. So here for a particular I, we are checking all the j's, or the logic that we have seen above. So for a particular j value, we are checking all the I. We are running the I loop from j minus 1 to 0. From j minus 1 to 0, we are running the I loop. So is it needed? Rather than if we have a j value, if we are standing at the j value, then I will just check what is the value of this j, what is the value of this j, what is the nums of j, what is the nums of j, what is the value it has at. So I will check only to, I will check only to that indexes, I will check only to that indexes, correct? Let's suppose, so how it is going to optimize. So if I take an array, so let's suppose we are running our j loop, so let's suppose this j loop is standing here, our j loop is here, so I loop is going to start from this point, I loop is going to start from this point, and it is going to run for all the extreme left, rather than can we, do we need to check for everyone? Let's suppose the value here is a, let's suppose here b, c, a, so something like this. So for this a, this b check is not making any sense, this c check is not making any sense, this c check is also not making any sense. So these are like extra, these are like useless iterations, these are like useless iterations. Rather than if we store when I am at index j, for a, how many indexes of a we have at. So for a, can we carry a dictionary kind of things, which is storing which of the indexes 0, 1, 2, 3, 4, 5, 6. So let's suppose for a, when we are at index 4, 5, index 6, how many a we have till now encountered, how many a we have till now encountered. We have a at index 0, we have a at index 1, we have a at index 3, right? This many a we have already encountered. Now I know as we are checking for I and j, nums of I and nums of j are identical, so that conditions are anyhow satisfied, because we are directly fetching our dictionary with the key as a nums of j, with the key as a nums of j. We will call our dictionary to dd of nums of j, and we are checking, and then we will iterate, we will iterate to the indexes where this a has appeared, then we will check if 0 cross, let's suppose whatever the j value modulo k, if this things is divisible by k, if it is, then increase your answer, and 1 cross j modulo k, if it is not divisible by answer, don't need to do anything. And let's suppose another one is 3 cross j modulo k is divisible again by your k, then increase your answer, simple as that. So rather than going to every indexes which are not identical, so here is a b which is not identical, here is a c which are not identical, here is a c which are not identical, so rather than checking all of them, I will basically carry a dictionary which is going to store which of the indexes this, for this particular nums of j where I am standing, which all the indexes the same value has already occurred. I will store that indexes. So this is one index, this is one index, this is one index, and I will iterate to the indexes only, So that is a slight optimizations we can put. That is not a slight optimizations, that is a quite good optimizations. But if you have a test cases like all are identical, let's suppose a. So if that is the case, then on worst case your dictionary like dd of a is also going to store when you are standing at this particular point, you are basically going to check for like all the indexes 0, 1, 2, 2, 3, 4, like all the indexes 0, 1, 2, 3, all the indexes, like that is nothing but if you can start I loop from j minus 1, and if you are iterating the same complexity we are going to. So when our all the values are identical to the given array, then the time complexity is still like of big O of quadratic only, big O of n square, but there is obviously a huge optimizations, because we are not going to check for every indexes, we are basically skipping the indexes, we are basically for which indexes of nums of j we are standing, for that indexes we are which of the indexes having the same value we have encountered before that we are just iterating to that indexes to validate the modulo conditions, the same code which we just explained in the one note, the same code I have written here. So here you can see I took the len of nums, I have initialized a default dictionary which should be a list, because for a particular value which of the indexes previous of the current value it has encountered, previous of the current index it has encountered. So here you can see, rather than writing it as a j, I can make it as a, maybe that will make a little bit more sense, and finally I will put my nums of j to j. This should work as it is. I'm just writing what I have explained, so that like you guys not going to confuse anywhere. So yes, it is should work perfectly fine. And now So you can see like it is 99.33% faster than all the submissions over the Leetcode. So I think it is the most optimal solutions for this particular question. So let's quickly do the code iteration. So we created the same dictionary that we just explained, discuss on the OneNote, and then we initialize our answer, and J starts from in, and for I we will iterate to the all the indexes where the nums of J has already encountered, and I am going to check if ij modulo k is 0, because that's the conditions only pending, and because the equal conditions is already handled by this dictionary. If that is the case, we are increasing our answer, and finally for the current nums of J, we are also pushing another index value, the current index value, because on that particular index also the J has occurred. So we are just pushing it, and finally we are returning our answer. So it is as simple as guys. So but the thing is, like, more than big of, like, it is still like on the range of big of n square when all the elements are identical. So now just quickly discuss the time complexity for this particular solutions, which we already did. You have to say on the interviewer it is big of n square, and along with please clarify for which test cases it is going to be take big of n square. The test case is when all the elements are identical. So for that test case, it is going to take the big of n square type. And on space perspective also, it is not a constant space. It is going to be take of big of in space also, because for every particular value we are pushing a key and the indexes which the particular value has occurred. So that is the time and space complexity of the most optimal solutions, I have to say. But it is some case, because you can see the optimal solutions we are is on the worst case is going to like more than worst than the brute force, right? Because on the based on the test case, because on the brute is going to able to done his job big of n square, and space it is not taking any space. But this optimal which we are stating as an optimal, it is going to take space. So that is a catch for this particular question. But again, like, please explicitly mention the solutions to the interviewer. That is going to add a cherry to your interview, particular interview, and that basically make yourself different from the other candidates. So please provide some approaches. So if the particular question only be solved with brute, then give the brute and tell why like most beyond of brute no optimizations is possible. Like, give the proof, give the like written proof for this. So that is a written proof of the kind of optimal versions of the brute. But there are catch, like it is going to, on the worst case, it is going to take off big of n square, and space also it is going to consume for sure for all the cases. So just give the taste of the interviewer. Like, you can think on the multiple approach. You can open to think of like multiple approaches. That is going to, so that actually on the industry we need it. If you are able to think on the approaches, like when you are working on some industry level project, you have to come up with multiple approaches for a particular problems, and out of them you should have the clarity of what is the pros and cons of a particular approaches you are coming with. So let's suppose you are coming with approach 1, 2, 3, and approach 1, let's suppose you are making as a preferred, and you should have a like supported evidence why it is going to be a preferred approach. So exactly that things I am requesting you guys. If it is a brute, then fine, but give a two-way door decisions kind of solutions, which is basically make yourself different from the other candidate. So I think that's it for this particular question, and I guess you guys are already doing, if you are able to understand the problems and the solutions that we did, please do subscribe to our channel, and please share the videos to your friend circles who are also preparing and also brush up their DSS skills, so that they can also get most of it. And also turn on the notifications so that when we are going to be live with our next video. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.